question is, let's say you're given a data and then you're asked to find the best model.
Okay.
You tried SVM, and then you can get multiple lambdas as the hyperparameters, and then decide within SVM which model is the best model. Right? That is one way. Instead, I try SVM. I try some other ML methods, maybe linear regression or logistic regression, depending on the type of problem. Then I want to compare across these models, so heterogeneous models versus homogeneous models. Any solution and model selection.
So currently this procedure does not care whether it's a homogeneous set of models or heterogeneous set of models, and the bounds also are insensitive to that, right? So if you want some procedure that respects this, then we should not do validation. We should do something more smarter. So validation is insensitive to this. It's agnostic to this. So, but did I answer your question or?
Yeah. See,
so are you asking for a better alternative,
right?
or?
No, we're using validation set for hyperparameter training.
Right.
Right. And if all the hyperparameters are coming from the same model family, model selection is very clear. The hyperparameter that performs the better, that minimizes the validation error, is the right.
Right.
Which is good. Then if I have another model set, and then I have validation data run on that model set, then I get one better model there. So I get from different model families, one best model that validates, that uses the validation data and minimizes the validation error. Among all these things, then you again do the final model selection, right?
You can keep on doing this. So if you are talking about again model selection, so you can again keep on doing it recursively. So if this is what you're saying, so previously there was model, which was set of parameters. Then we came to set of models. Then you can talk about families of models. So this is exponential family. This is some other neural networks. This is some other family, and still again do one more level of parameters, hyper parameter selection. All this you can do, but everything you need additional data. That's all. Then you will need three kinds of data: training set, validation set, hyper validation set. Right? But usually people stop with two levels. Whether it is heterogeneous or homogeneous models, whatever it is, they just do one step of model selection with one set of validation data. And that is good enough. Just by increasing the number of levels recursively, nothing is achieved. Okay, so two levels what you can achieve with n levels also. There's no big difference.
Okay.
So you are understanding, right? Even model selection, I can make it flat. See, here is one way of making model selection flat. I can so I can actually come up with a model which is a union of all. Why should I do model selection? I'll just take a union and just do one flat parameter estimation using the entire data. I can do that also. But people found typically that this paradigm is better, that if you have multiple carefully designed models, then take each of them, then take the best of them. That's the two-step process is far more generalizing in practice than this flat model, than more hierarchies. So you can also create more finer hierarchies from the same set of models and keep on doing it. So this also is not great. Flat is also not great. That's what people found out. Exactly two levels is the most convenient, most popular structure. So I think now did I answer your question?
Yeah.
Yeah. So this is the thing. If you have multiple models, then also I can come up with a flat model like this and just do parameter estimation using the entire union. Or I can keep creating finer models and create a hierarchy out of it, a very complicated 10 level, say a 20 level hierarchy, and then keep on doing this validation set recursively. But the entire data set that has been given to me is constant, right? So whatever it is that I will have to break it into multiple parts. We'll come to that now anyway, but I'm reading because Bhatt has already gone through this for the second time.
Sorry.
So the information in the entire set is same. So whether you distribute it into 20 things or into 2 things or 1 thing, the information is same. But people found out that the 2 level hierarchy is most, efficient in some sense. Right? Okay. So any questions, please? So did everybody else understand this question about hierarchy and the flat thing which I said, or should I give more details?
Sir, please give more details.
Okay. See, here is one option. So let's suppose somebody said, I have all these models, do model selection. In model selection, what are you doing? You are getting the best of these models and then coming up with the best of these bests, right? Do you agree that it's a 2-step process?
Yes.
Okay. So this is like a 2-level race. There is it is like semi-finals and finals. So this is like semi-finals. This is finals, right? The competition can be held like this, or the competition can be held in the following way. I'll put all these fellows to run in the same thing. I'll put all these parameters in the same model. Okay, I'll create a union model basically. I'll make them run together. Okay, one test, one run, that's all. And I'll select the best. Right? This is the other way. This I am calling as flat. This I am calling as 2 levels. So everybody understood 2 levels and flat? If this is not clear, I can again explain. Okay, maybe it's not clear. Let me explain with an example. Suppose you were to decide the fastest runner among animals in a forest. Okay, let's assume there are 3 kinds of animals in forest: lion, elephant, and monkey. And so there are many ways of conducting competition. One is, first you decide who is the best monkey, best elephant, best lion, best in the sense fastest. Then for those fastest you will put a race, correct, and then select the winner. Okay, so this is similar to 2 levels. Or you can do a flat race in which you will put all monkeys, all elephants, all lions in one track and ask them to run, and then select one winner. That's I'm calling as flat. So everybody understood 2 levels and flat?
Yes, sir.
Now the other option is you can in fact create a bigger hierarchy. So you can keep on doing this. In fact, you can say monkeys are also of 10 kinds. Maybe I don't know. Somebody knows names of monkey populations? Some special subspecies of monkeys?
Lemurs,
Orangutans.
orangutan. Lemur, LEMU, or orangutan.
Orangutan, something. First, I'll make orangutans run. Then I'll make some other things run. Something he said. Then out of all these winners, I will make them run. Then I'll get the best monkey winner. Then similarly for some elephant subsets, then I'll get elephant. Then I'll get lion. Then again I'll make these 3 run. I can build a big hierarchy. So I can do this in any of these fashions. First of all, do you all agree? In the animal example, all these 3 options are clear to everybody?
Yes, sir.
But in the animal example, whether you do it in 2 levels or flat or hierarchy, the final winner maybe is the same, right? Assuming there is no fatigue, assuming the tracks are same. Yes or no?
Yes, sir.
But now in machine learning, the tracks used in each of the competitions is different. Okay, it's like the tracks are different. For example, in case of the 2-level hierarchy, the monkeys are actually tested on a monkey track. Maybe they are tested on how fast they travel through trees, hanging on trees, maybe. Okay, and then M2s, elephants are tested on road, maybe, and maybe lions are tested on, I don't know, maybe a combination of some grass and I don't know, right? Okay, then you will select best out of them. Then the best of all will are made to run on a new track. Okay, and this track could be none of the old tracks. So this is like saying my data set is different, right? Understood?
Yeah.
Okay, so in machine learning, the exact analogy is that the monkey track, the elephant track, and lion track are all the same. That's the training set. But in the second race, I use a different track, which is called as validation set. Okay, why track is same as this data set? Because that's what computes the error, right? So the difficulty of the track is same as difficulty in the data set, right? So it's like, okay, whereas in the flat, you may get a different answer because I may choose a different track here. Here the track is Trainian Union Validation. That's a different track. On that, who wins could be different from this winner. Do you guys agree that they could be different?
Yes, sir. It can be.
Similarly, this hierarchical winner also could be different. It basically depends on what are the tracks. If all the tracks are same, then all these will give same answer. That's like saying if everywhere you use training set and nothing else, you will get the same answer. That is true even in machine learning, right? So if you use the same data set everywhere for hyperparameter tuning, parameter tuning, then actually there is no need of doing model selection. You can as well make everybody run together and declare the winner. Okay. So this is what I am trying to say, that in machine learning, people found out that this 2-level business is the most efficient. Okay. And this is just an empirical observation. Okay. The empirical and convenience and all these issues are there, right? Based on all of this, everybody does the 2-level thing. Nobody does more than 2 levels. Nobody does less than 2 levels. Okay. Any other questions, please? Now the difference between W hat and W bar is like saying, okay, I found out that maybe, lions are the best model. That means lions are the best species in terms of speed. But to pick the best lion, I'll not simply use the lion track. I'll actually use the entire track, which was used in the finals and semifinals. That's like saying I'll use the training set and validation set. Okay, so that winner lion could be a lion who was not used in the finals actually. That is possible. That's when W bar is not same as W hat. Okay, any other questions, please? And if suppose the lion batch is too diverse, right? There are very, very weak lions. There are very, very strong lions, fast lions, strong lions, weak lions, slow lions. Suppose it's very, very diverse set. Then what do you expect? You expect that on different tracks, you will have different winners, right? Okay. But consider a case where the model is more simplistic, that there are only fast lions. Then irrespective of the track, the winner will be the same. So that's exactly what is happening in model complexity when you use maximum discrepancy as the model complexity. So if you have complicated models, then the winners will differ with respect to the samples, like how winners differ with respect to the tracks in case of a running race. But if your model was very, very simple, then what will happen is the performance will be equal among all tracks. Of course, if the model is simple but bad, that means instead of lions they are say elephants, then they all of them will walk slow. They are homogeneous, but all of them will walk slow. Okay, but if they are lions, perhaps all of them will walk faster, run faster, right? So you want models that are simple as well as well suited for the application, right? That means which are fast, right? So that's the best model. So that's exactly what is happening in this model selection validation procedure, right? So I hope the analogy has given some insight into the understanding. If we have still some more questions, I can take them. Okay, so there's one more comment I wanted to give, one more detail which I want to give in case of validation procedure. That's the following. Now, I said somebody will give training set. Let's call it DTR. Somebody will give validation set. Right. Now, in practice, what happens is typically somebody gives only one set. And what you do is you create two partitions out of it. One you use for training, one you use as validation set. So this is what you will do in practice. Okay. So is this point clear? People usually don't give two, I mean, sometimes they may give, but typically one may give a huge data set and ask you to do machine learning, whether you want to do the flat model or two-layer model, whatever is up to you. So somebody may give one flat data set like this. And if you want to do the two-step procedure of model selection through validation, then you will split it into training and validation. So is this point clear?
Yes, sir.
Okay. Now, when you are splitting, you have to somehow make sure that these two actually come from the same distribution, right? So somehow you have to make sure that this happens. Okay, then there are ways to do it. Okay. So, but the only point I'm trying to say is you have to make sure that these two actually come from the same distribution or appear to come from the same distribution. Otherwise, your IID assumption won't hold. Okay. For example, if you sample only points from, suppose there is a 3-class classification problem. Suppose in training set you take only 2 classes, and in validation set suppose you take some other 2 classes. Then these are not going to be IID for sure. Okay. So you have to try to make sure that the samples appear to be IID, at least when you do some kind of statistical tests. Okay, that's one point I wanted to mention. Thirdly, whenever you are doing such a split, right, there are m samples, the most reasonable split is m by 2 samples here, m by 2 samples here, say. Okay. Now there's a dilemma, right? The dilemma is that for doing parameter estimation, I'm using only m by 2 samples. For hyperparameters, I'm using only m by 2. So essentially, I'm not using m samples for any one of them, right? So one way to, there is a clever sampling technique, which will make it appear as though you are using almost m samples for training and m samples for validation. That's a very clever sampling trick. Let me explain that trick now. Okay. So suppose the entire data set given to you, it has say 100 samples. Now you will break this set into say 3 parts, 3 folds. These are called as folds. Okay. So when you break them, you again have to ensure that all of them appear IID. So maybe these are 33 of them, suppose 99 points. These are 33 of them, these are 33 of them. Okay. Then what you will do is you will first use, in the first iteration, you will run the procedure 3 times. In the first time, you will use these two folds as training set and this alone as the validation set. This is the first time. Second time, what you will do is you will use this and this as training, this alone as validation, and in the third time you will use what combination is left? This and this and this is over, this and this is over. So this and this is left, right? So this and this. So these two you will use as training set and this fellow you will use as validation set. Okay. Now in each of these iterations, you will compute, again you will do validations. With this training validation, you will do a usual validation procedure and come up with, for each of your models, W1 to W1 hat, you will come up with notion of error. This is error 1, this is error loss or error or empirical risk, whatever you want to call, right? And then you will basically add up all these errors. Okay. And then select the one that minimizes the sum of all of this. Okay. So you'll basically select that model which minimizes the empirical risk or validation error across the folds. That's what you will do. Okay. Now this is a very, very clever sampling procedure. And what you can show is through this procedure, you almost use M samples for training as well as M samples for validation. Okay, so how that clever sampling works, that's beyond the scope of this course. But this procedure is called as cross validation. So this is called threefold cross validation. Similarly, you can talk about k-fold cross validation. Okay. So everybody is clear with cross validation? So these are again things which can be learnt by your own, but just for completionist sake, I'm repeating them in the lecture. Okay, so there's just one more detail I want to give. Typically in machine learning, when you do it in academia, you would also want to know how your final model performs in practice, right? So what you typically do is the following. You are given a data set. You will actually break it into three parts. Till now I said two parts, but hold on. You will break it into three parts: training, validation, and test. Okay. Now this test set will never be used in machine learning. Okay. Please keep that in mind. This test set is purely for academic purposes or evaluation purposes. Okay. So in fact, it's also called as evaluation set sometimes. Okay. So this is just to know how does your final classifier model combination work, and what will you do with that final evaluation? Nothing. Okay. You should not further train. Okay. So now with this union, you can actually do a cross validation also then. K-fold. Okay. So this is what it happens in practice. Usually a set is broken into two parts, maybe train validation combination and test set. And using train validation combination, perhaps you will perform a k-fold cross validation and come up with the right parameters. And the right parameters are evaluated on this and just left like that. Because your final answer is this. Only thing is you also know an estimate of how much is the loss, expected loss over the evaluation set. Okay. So in case you are using test set in your machine learning application at any point of time, that's like cheating. That's like leaking the exam paper in JEE exam, right? So please don't do such mistakes. And
so, sir, one question.
Yeah.
So, on the assignment you have given, right? We have training
Right.
and test set. So, you mean we should not use the test set, or is it a validation set? with that.
See, if somebody says test, it is test. If somebody says validation, it is validation. There is no confusion. Okay. So nobody will formally write test and say you can use it for validation. Okay. Unless he's not being formal. Okay. So that's what I'm saying. So somebody leaks the question paper, JEE question papers, and says, no, it's just for fun. Okay. Either he does not know the value of JEE exam, or he is trying to cheat. Right. So who will try to use, say test is same as validation? Only if somebody does not know the importance of this categorization, or somebody wants to cheat, right? So please be careful. If in the assignment somebody says test, then he means test, that's all. And whatever is remaining, you can maybe break it as training, validation, whatever you want to do, you can do. But test is sacred. Okay, do not use it anytime in your machine learning entire pipeline. The only place where you have to use is finally somebody asked you to evaluate yourself or evaluate somebody, and leave it at that. There only you will use the test set or evaluation set. Is this point very clear?
Yes, sir.
Okay. So if somebody by chance says, I have split it into two parts, training and test, what he actually means is test is test. Training you can further split into training and validation, or you can do cross validation, whatever you want. Okay. But do not assign test as something else. That's all. Training and validation, you play with them, you take union, you do a flat process, you do a 2-level process, hierarchical process, whatever you want to do, that's fine. But test set, never play with it. If somebody designates something as test set and you are finally evaluating your performance on that, never use it. Any other doubts, please? Okay, so in this today's lecture, I have covered kernels and I have covered model selection. So these two are the main things which I have covered, and that makes you almost prepared for the simulation assignment. There is only one part which you will still need, which is on k nearest neighbors and non-parametric estimation. Now these methods are very simple. I will at most perhaps take 1.5 hours for that, or 2 hours. Now I have the following request for you. Now the deadline request or suggestion, I don't know. I can cover the portion in the next week lecture on 19th, and then that will be very close to your deadline. If you prefer, I can take an extra lecture either tonight or tomorrow anytime, or on Monday night, and cover up. That is only if you want. If you guys don't want, I can always teach it on 19th. But the problem with 19th is it is very close to your assignment deadline. So perhaps some of those methods which are based on nearest neighbors, they will have to wait. Of course, without teaching me, you can always go ahead and learn them and use them, or coding them in the final moment using some codes which are available on the internet and just running them will not be difficult. But given that all of you are working, I would not go with that option. So whatever you guys tell, I am happy to do it. But let's not postpone the deadline, because already we are going very, very late. There are 2 more assignments that have to come. And if we postpone this, those will get postponed. And so unfortunately, this break was too big in the... If we had finished the portion before the break, it would have given you a lot of time, but that did not happen. So if you want to discuss over the form, that is fine. Or if you want to tell some opinion now, it is fine. Okay, nobody is speaking up. Let's discuss over classroom. Whatever you want to do, I'll be happy to do it as per your...
So, what are the topics we would be covering in the class? Let's say.
So in the extra class, I just that is going to be for around 2 hours. I'll try to do it in like 1.5 hours, 2 hours. The only topics will be k nearest neighbors and KD, kernel density estimation. Right. So these methods. So these are the two non-parametric estimation methods which I will be teaching, and they are included in your simulation 1 assignment.
Yeah, right.
Also, sir, regarding assignment, right? Actually, there is a case like NLP need to be applied. So, can we go ahead and use the same exact code mentioned in that
See,
for
please
NLP,
feel
or
free to
do we
use
need to?
any code which is available on internet. You don't need to code anything by yourself except the wrappers. This is only for understanding of the pipeline, right? So this is only
Yeah.
right. So I don't expect you to understand NLP intricately, nor understand gradient descent, those solving methodologies for SVM. I did not teach you, right, those things. So that is
Okay.
not the goal.
But for
So please feel
classification,
free
we
to
need
use,
to
let me finish. Please feel free to use any code which is available on the internet, and you don't even need to acknowledge, because I'm not asking that in your report. But when I ask you to submit, if I see all the things, so suppose somebody, see, you are free to use something on the internet, but you should not, you copy from your friend. That's all. You should not take his code. Everything he does, whatever he reports, you just report, right? That is not allowed. So if I see two reports very similar, I'll catch you. I told you what are the ways in which I can check closeness, right? So that is the only thing. Otherwise, whatever is available on the internet, if you want to use code, please feel free to use. You don't even need to use the libraries I suggested.
Okay, sir.
Does this clarify your?
Yes, sir. Yes.
Sir, but what about the richness of features that you asked to design?
That's what, right? See, it's a matter of excellency, right? So see, there is always some score which I will give to students who go out of their way and read those papers and perhaps use some codes in those papers and carefully design their features. They should be rewarded, right? Don't you think so? Compared to some other student who does not read the papers, he just takes the suggestion of bag of words, so some simple thing he has given, right? Just use some basic features and do the job. There should be some reward for a person who goes through all those material. Yes or no?
Yes, sir.
And for that you will need time. So I basically wrote all of this email. So you decide whether you want to go for excellency or just normal grade or low grade, and then work towards it. If you want excellency, you will have to spend a lot of time. You should go through those papers, understand where they have written the codes, download them, maybe carefully build your features, then use them in the code, right? Or if you don't want to do any of those things, you can do a simple pre-processing which just counts the number of words in the text and just uses them as it is. That's very simple to write. That will not take you time, but that will not give you too many marks also. I'm not saying it will not give you marks. It will not give you the top grade. That's all. Is that fair?
Yes, sir.
Yes, sir.
Okay, I really have to go. If you have any questions, you can ask over the forum. Thanks. Bye.